Hello, and welcome to our Introduction to the C programming language. This is session number 7. Quick recap from last time. We went over arrays and the details surrounding them, initializing them, stepping through them, passing them as arguments to functions, etc. This time we'll be going over file I/O, standard I/O, a brief note about character encodings, and we'll be demystifying the printf function that I've been using this whole time. So, in C, everything is a file, or rather, everything that isn't just in the source code or in memory is treated as if it were a file. There are two ways that you can deal with files in C. There are the high-level functions that will pass you an abstraction called a file pointer, and you just pass this file pointer around to anything that will, or to whatever you need that will modify this file, and have those functions deal with it for you. Or there are the low-level operating system specific options that pass you the file descriptor directly, and you use the low-level functions to deal with the nitty-gritty details of exactly how the file is manipulated. I recommend using the higher-level functions because they're a lot easier to use. The main thing for getting a file open in the first place is a function called fopen. This is found in standard io.h, as are the rest of these actually. And the signature is down here on my pointer here. So fopen takes a string file name. So this can be a relative path from wherever your program is being run, or it can be a absolute path that is the full path from the root of the file system to wherever the file is on the disk. And then it takes in a constant character pointer or a string mode. The modes are all down here. I'll go over them real quick in a moment, but this file pointer structure here, when fopen returns you this, it is not something that you're supposed to dereference like another kind of pointer. This is meant to be passed around, and the file pointer's job is just to hold the pointer in memory. Under the hood, all of the functions deal with the file pointer for you. So the modes that fopen can take are R, which will just let you read the file, and specifically these are hints to the operating system. I think you can violate these, but if you can, it's poor practice. If you can't, then the system is a little more bulletproof than I thought it was. Anyway, so R lets you open an existing file for reading purposes. If the file does not exist, it will hand you a null pointer. W will open a text file for writing. If it doesn't exist, it will create one. And if it already exists, then the program will still start writing from the beginning of the file, so you will lose anything that is in that file. A opens a file for appending. So it's basically, it opens the file for writing, like in W, and then it sends the file pointer all the way to the end of the file, so you can start writing from there. R plus opens a file for both reading and writing. W plus opens a file for both reading and writing, but it sets the file length to 0 first. So anything that so the whole file gets loaded into memory, and then anything you write will be the only thing that exists in that file. For regular W, it basically loads the whole thing into memory, and then you start replacing characters. So anything that you don't replace is left behind. And then A plus opens it for both reading and writing, lets you read from the beginning, and starts your writing at the end of the file. So it's kind of a combination of R and A. Standard input and output. It's a little difficult to describe these given the current modern paradigm of graphical interfaces, but in the old days, all we had were terminals, and there weren't many graphics. You just had command lines. And it's easier to understand what standard input and output are in terms of command lines. So let me actually just pull one up here real quick. So this is my command line. When I run a program on this, like say I'll just run cat for an example, and what this will do is it will just take anything I type here. So C is easy, and it will print it back out to the screen for me. It just echoes it back. There are two files in use with cat. The first is standard in. That is my keyboard, or more accurately, it's the terminal program itself. Whenever I type like this, the terminal emulator has whatever I've been typing stored in memory somewhere. And then when I hit enter, it realizes that I'm done and sends that line off to whatever program is currently running. And then the other file that's in use right now is standard out. Whenever the program cat decides that it needs to write something to the screen, it sends that off to the terminal emulator, and it gets spit onto the screen like this. There is a third kind of file that deals with terminals like this, and that's called standard error. I don't have an excellent example of that right now. Let me just end that. But basically, what standard error does is it prints out to the same place as standard output in these circumstances, but it does it in a different way. Standard output is buffered. What that means, let me see if that, there we go. What standard output being buffered means is that whenever a program tells standard out that it wants to print something out to the screen, standard out holds that for a moment and prints it out basically whenever it finds it convenient to do so. Standard error, on the other hand, is considered urgent. Whenever you print to standard out, it will dump the characters to the screen about as quickly as it gets them. The reason for this is because the error messages are generally considered more urgent than regular output. In a C program, standard in, standard out, and standard error are all identifiers for these standard file descriptors. They are defined in... they're not built-in keywords. I think they're defined in standard io.h. But you can use those whenever you would otherwise need a file pointer. There are two functions used for getting input from the keyboard one character at a time, and for putting characters on the screen one character at a time. The one for getting characters from the keyboard one character at a time is getChar. What getChar does is it reads from the current standard in buffer and returns whatever it gets as an integer. And what this means is, suppose I call getChar. I actually have a quick piece of code right here that'll just demonstrate this. So in this, I have the same line twice in a row. I just printf one character, and the character I get is from getChar. What will happen here is... I need to open up a terminal emulator here. Doop, bash, there we go. So, if I've already compiled this, and so we can see that the program is hanging here. It's not going back to the terminal prompt, but it is giving me freedom to type here. So, what will happen here is it's going to hang until I hit enter. It didn't get anything, and it's confused, so it's asking me for input again. Well, that's not quite true. It didn't get anything, and so it spit the nothing I gave it back out to the screen. If I do this again, what happens when I type multiple characters in is it will not ask me for input multiple times. Instead, it will print the first character out to the screen, and then because there is still information in the standard in buffer, it will print the second character out to the screen, and then everything after that stays in the buffer, but the program ends, so it just throws it away. Putchar will just take in a character and dump it to the screen instantly, or to wherever standard out is set to go. Yeah, putchar and getchar are fairly simple, but they're often a little too primitive to be used at scale, which is why we have other functions in the standard I/O library. Moving on, we have character I/O functions and formatted functions. Formatted output, like printf, is used for It is used to make outputting things to the screen considerably easier on the program. Printf is a special kind of function called a variadic function. And basically what that means is it can take in any number of arguments of any different kind. And under the hood, there are special ways to deal with functions like that, but it's a little advanced for this course. Basically, you can pass printf anything, and so long as you give it a heads up, it'll know what to do. That heads up in this case is done with format specifiers. Format specifiers are a special kind of string that you feed to functions like printf that tell it what kinds of data to look for in the arguments. So you've noticed that whenever I was outputting a piece of data to the screen, I gave it a code that kind of looked like this. It had % and then a letter afterward. Those letters tell printf, I am giving you a particular kind of data here. And what it does is printf will note the order in the string that the format specifiers are, and it expects the kinds of data to occur in the arguments in that same order. So, if I go to the next slide here, I have a handful of basic format specifiers. The actual full list of format specifiers for printf is absolutely huge. I couldn't go over it in the time we have. I encourage you to look it up on your own and play around with it some. But the very basics are %d will convert it to a decimal number or an integer. %c will convert whatever data it's given to a single character. %s, it expects a C string, or a constant character pointer, to be passed to it. %f will output the data it's given as a floating point number, or a float or a double. By default, it has a precision of 6 digits, but some of the advanced things that you can pass to printf will let you play around with this some. There are special characters called escape characters. We've been over these a little bit before, but passing these escape characters to printf will have it print them in whatever way it knows how. As we've seen in my earlier examples, these format strings can have regular text in them, but it's this % symbol in front of one of these specifiers that will tell printf how to format things on the screen. If you need an actual % sign in your string, the format specifier for that is %%. And that's just a way for printf and anything else that uses a format specifier to be able to deal with that sort of thing. Here is a list of commonly used file I/O and character I/O functions, or rather their function signatures. For character input, we have fgetC, which takes in a file as an argument, and it just gets a character from that file. getC, which is very similar. getChar, which always gets it from standard in, and ungetC is weird. Basically, it takes the character you give it and pushes it onto the front of the file stream. It's kind of a way to put a character back where it came from when you're reading from a stream. It's very weird and very, very situational. Output. You have fputC, which just takes a file and a character and an integer character and pops it onto the screen, or pops it onto the file stream you give it. putC does something similar, and putChar does the same thing but will only do it to standard out. String input. fgetS. This is what you're going to be using most of the time when you're getting strings from files. So you pass it a pointer to an empty string. You'll notice that it's not a constant character pointer, just a character pointer. Int n is the size of the buffer you give it in S, and stream is the file you're expecting the input from. What will happen is fgetS will read from the file until it finds a new line character, that's the /n, or until it gets to the end of the file, or until it reads n-1 characters. It leaves that last character as a guaranteed null character. So that way you don't risk having something try to read S later and have it not find that null character and go, frolicking off into memory it's not supposed to. Typically, what you want to do when you're getting input from a file is load a whole line into fgetS, process that however you need to, and use a handful of string to number conversion functions like a to I or a to f to convert those into integers, into floats, into whatever else you need. This is the safest way to deal with data from files. getS does the same thing, except it doesn't let you tell it how big the buffer is, and it only gets it from standard in. This is very, very not safe. Again, because getS doesn't know how big the buffer is, if you type more characters that it can handle, it'll just try to load them into memory there. And at that point, it's a toss-up between whether you've corrupted your own memory or whether you've corrupted someone else's memory. The operating system notices and crashes your program. String output at the bottom, you have fputS, takes in a constant character pointer, so a C string, and a file stream, just dumps that string into the file stream. PutS does the same thing, except it just dumps the string you give it to the screen. It's like printf without any of the bells and whistles. Quick note before we end this off on character set encoding. There are a ton of different character sets and character encodings out there in the world. Usually when you're dealing with source code, you're dealing with ASCII. And when you're dealing with a terminal emulator, like you are when you're doing this kind of basic C programming, you're dealing with ASCII. However, there are situations where you will need non-ASCII character sets. Usually this is for pretty advanced projects that deal with like Windows GUIs and things like that. But there are other smaller situations where you might need them. C has built-in ways to deal with what's called a wide string. But they're not the safest thing to use because the way each platform deals with wide strings is not very convenient. And if you try to print a wide string to the screen, it gets undefined behavior. So generally, I advise staying away from those. There are libraries that exist to deal with non-ASCII character encodings, and they're fairly easy to look up. You can just look up the name of the of the character encoding plus C library. C++ tends to have better support, but there do exist libraries for C. Under most circumstances, situations where you need non-ASCII strings are best handled using localization files. What those are is files that are full of strings used in your program that are translated to different languages and character sets. And what you'll do is you'll have code to recognize what string needs to be output here, and we'll pick a string from the localization file depending on what locale is selected in your program. It's a pretty niche kind of situation, but I felt it kind of important to quickly go over this sort of thing. In summary, file I/O is complicated, and it's difficult to go over in a 15 to 20 minute slide deck, but this should be enough to get you started, and it'll give you enough to play with and continue research on your own time. Next session, we'll be going into debugging. You'll be doing a lot of debugging when you're programming, especially with C. Because unlike newer languages with more complex runtimes, C is pretty close to the middle. C operates much like the computer does. As always, there are live coaching sessions for software design, software engineering, C and C++, among other things, available on the website. There are other courses that will be available soon. And thank you for joining us.